There is a subtlety in this program that I feel obliged to point out, and it is this line here, where when we get close enough to the destination, we set the subdestination equal to the destination. And this should give you pause because both of these are arrays, and in Java, arrays are reference types. So the variables do not hold the arrays themselves, they hold a pointer to the arrays, which live in memory. And this can get you into trouble. Let me just show you an example of how it can get you into trouble. So I'll reproduce basically the situation we have. I'll make a variable of a reference type. I'll make another variable, the same reference type, and set it equal to the first one. Then modify the value of that second one, much like we do down here when we modify subdestination. And then I will check the value of the first one. And what we'll see is that modifying that second variable has actually affected the first variable. And again, that's because these are reference types. The variable a does not contain this array. It contains a pointer to that array. The array itself lives in memory, and this keyword new tells Java to allocate a new chunk of memory to hold that array. Without calling new, you don't get a new chunk of memory. So when we assign B to A, since they're both reference types, what that line means is point B at the same thing that A is pointing to. So there's only one object, there's only one actual object, but there's two references to it. So A and B are different names for the same thing. So when we update this value, we're updating the value of the thing in memory. And A is pointing at that same thing. So when we output it, we're saying output this value, and it's the same value that was just modified. That's why we saw 10 output to the console. So you can get into trouble with reference types because you may expect that this line just modifies the value of B, but in reality, it's also modifying the value of A since A and B are referencing the same thing. So how are we actually avoiding problems in our program where we're doing this, where subdestination and destination temporarily point to the same object in memory? The reason is because that is true. They do point to the same object in memory from this point onwards until we check if we've reached the destination. And once we actually get to that final subdestination, which is the destination, this check will return true. So we'll pick a new destination. And if we go look at that method, this method gets a random position, and getting a random position uses this new keyword, so it creates a new chunk of memory that destination is going to point to. And so at this point, destination, subdestination once again point to different places in memory. So we're free to update subdestination without affecting destination. So to illustrate, initially destination is pointing to its own chunk of memory. Subdestination is pointing to its own chunk of memory. Once we get close enough to the destination, we make subdestination point to the same chunk that destination is pointing towards. And once we get to that final subdestination, we pick a new destination. And we allocate a new chunk of memory, and destination now points there. So subdestination is pointing at the place in memory where the destination used to be stored. And we update this one here in future iterations of the animation loop. Of course, at some point, we'll get close to the new destination, and then subdestination will point to the same place in memory the destination points to. Once we get there, we'll allocate a new chunk of memory, and destination will point there. So this is how we avoid trouble. Yes, subdestination and destination point to the same place temporarily, but as soon as we reach that subdestination, which is the destination, we allocate a new chunk of memory for destination to point to. So modifying sub-destination will not actually alter the destination because they no longer point to the same thing. So that's the subtlety I wanted to call out. This is a somewhat dangerous thing to do because if, say, we had written the set destination method differently, whereas instead of newing up a new double, we had instead just modified the existing one. Say we did something like this. And if we do this, we'll have to explicitly initialize destination to begin with. So if we had done this, which seems like a perfectly reasonable thing to do, it's not that different than what we're currently doing, then we never allocate a new chunk of memory for destination. So after this first assignment of sub-destination to destination, these two variables will refer to the same chunk of memory for the rest of the program. So initially, until we get to the first destination, things will behave as normal. But once we get there, from then on out, sub-destination and destination are the same thing. So every time we've reached the sub-destination and we check to see if we're also at the destination, well, yeah, we are, so we'll pick a new destination. So now these two terms have just become the same thing. So we'll fly to new sub-destinations continuously. Let's see that. So behaving as normal for the first destination. And once we get there, you can see we're reaching the destination very quickly because it's the same thing as reaching the first sub-destination. So moral of the story is be careful doing things like this with reference types. Make sure you understand what reference type means and how you can get into trouble using it this way.